Welcome. So without further ado, let me just explain how this series is going to work. What I'm going to be doing is we're going to be going through an entire project. In this case, we're going to be making an homage to what you see in front of you at the moment. And throughout this series, I will go through the proper steps based on basic understanding of computer-aided design on how to create, CAD models and assemblies and all of those different things, all in the one series while doing one big project rather than separating them into hundreds of tiny little projects that don't really tie together. What we're going to be doing here is we're going to be making one big thing. And throughout this, all the proper skills and everything that you would need to know in order to use computer-aided design like Fusion 360 in this case is going to be thoroughly explained. I always prefer this idea than just going off and doing 5 to 10 minute tutorial videos, because it's easy to lose track of them and, well, not really track, but interest into them, since none of them really tie into each other. So what you see at the front, or what you see in front of you at the moment is a model which I have managed to make Inventor scream for its dear life. This is essentially a 4-cylinder engine. There is a lot of parts missing, so if you look at it and you know engines, there is a lot of parts missing, but this is just a concept view on how it's supposed to work, where you've got your you've got your cranks, rods, pistons. They go up in cylinder bores. This is not a block. These are only the constraints. The block has not been created for this particular project, and we are going to be creating a block and everything like this. That ties into those gears, which goes into the cam, which then pushes on the push rods, which then pushes on the lifters, and the lifters push on a flathead design like they had, I think, like back in the 20s and 30s, or however long ago they had the flathead design. There is an issue with this model, however. It uses certain types of joints which make Inventor scream for dear life, which means that until when I was fiddling about with one of the valves and getting that set up, it worked perfectly fine, nice and smooth. However, the moment that I got all 8 of the valves to be properly constrained, we end up with a huge mess like this. Let me just show you how slowly this works. If I can actually drag this, thank you. So this is about the best performance you can expect from this, to be honest. And Fusion is just screaming for dear life. So the idea here is that we're going to be making an engine. This time, instead of going for a 4-cylinder engine, we're going to be making a single-cylinder engine. That's going to reduce the constraintional load on Inventor, who clearly is not well optimized to run certain types of constraints in such a particular fashion. So hopefully that's going to be solved by reducing the amount of cylinders. And let's just get into it. What we're going to do is we're going to start by defining a certain amount of parameters, and we are going to be making this properly, so we're going to be using a lot of parameters inside of Fusion 360. So what we're going to do first is we are going to go and open our OneNote or any kind of drawing software. You can use a piece of paper, whatnot. And we're going to be doing a little bit of what do we actually want to create. Well, first thing first, we are going to be doing a overhead cam system. So that means that whereas in this you've got the cams at the bottom and they have push rods which then push on lifters which push on valves. What we are going to be doing is the cam's going to be when cylinders here, cam's going to be up here, and the valve's going to be down here, broadly speaking. So it's going to be overhead cam. We are going to do 1 cylinder, and it's going to be an air-cooled engine. So we're going to start it with an air-cooled engine, and maybe we'll make the water-cooled block, but we'll see how that goes. The block generation process is going to be a little bit different than you may think from, but yeah. Today, however, what we're mostly going to be focusing on is creating the pistons, and roughly speaking, this is how it's going to look. There are parameters that we need to define in order to make everything work. So let's just zoom in a little bit on this, and what we're going to notice is that we need to define some dimensions. We are going to start and say that our bore is going to be 86 in diameter. I am just eyeballing these dimensions. These are not really important dimensions at the moment. We're not defining the cylinder wall thickness at the moment. That's not important. We're not creating the block till the very end, which sounds a little bit backwards and probably is. But the way we're going to create the block is not through additive manufacturing like you would do in kind of CAD software. What we're going to be doing is actually subtractive manufacturing, which is going to make our process a lot more parametric later on. And we are doing a square design. So a square design is essentially that your piston travels up and down the same amount that it is wide. So this is going to be 86 as well. The height of the skirt is also going to be important. That's going to define certain parameters. So your piston skirt is going to be this. And this dimension right here, it doesn't really matter what we make it at the moment. Let's play out with some numbers. Let's make that 25 now. It doesn't really matter what it is at the moment. Let's just, we're going to work these numbers out later on. And then this is going to be the wrist pin hole, and let's make that a certain number. So we're gonna make this, let's say 15. I have a feeling that this is gonna be bigger, but we'll cross that bridge when we get there. That's perfectly fine. Now, if you take the section of this like that, so this is your section AA, and this is A to A, and we are just looking at half of it. So we're not looking at the full section, we're looking at half of that section. What we're looking at is essentially the inside of that wrist pin. So right here, you have that pin which goes through here, and that pin is going to kind of go up here and butt up against this. But something needs to hold it in place, and it's going to be a circlip. Now that circlip needs to have a groove like this, so it can actually fit here. Now, it doesn't really matter what dimensions we go for at the moment. We will cross that bridge when we get there. But let's just say that the height. So this is your center line of the hole. So that's the hole right there. There's your center line of that hole. Let's make this, so if this is 25, let's make this, let's not put dimension there. We're gonna figure it out as we go. And this is gonna be the underside of the piston. So you can see that there is a groove that is cut out right here. Now that is because our wrist of the rod, I suppose that's what you call it, since you call it a wrist pin, and it's gonna be here, and you're gonna have the wrist pin which is gonna go all the way through here, kind of like that, broadly speaking. So just kind of visualizing and trying to understand how this is gonna work, so we can actually start getting the parameters right. And another few things that we'll need to define while we're going there is our piston ring grooves that go inside of the pistons, which are these things here, or as you can see them, they're drawn as lines over here. The important dimensions is going to be from the top of the piston to here. Then there's going to be the separation between them and the actual height between them, or the height of the groove. And then you're going to have the depth of the groove, which I cannot draw here, but it's going to be like that. And the important thing is that these two, so this one and this one, they're going to be pretty much the same. This one is going to be taller because it's our oil scraper ring. It works different to our compression ring. Another thing that we will define and create today is going to be our actual piston rings and our piston ring dimensions. So if you look at this, let's say this is our piston right here, and this is the groove for the piston. Our piston ring sits here. So what we need to be conscious of is how are we going to parametrize our piston rings. As there is going to be a slight gap here, right here, and the piston ring is going to be butting up against this. So we know that the outer diameter of our piston ring is going to be the diameter of the bore, but the inner diameter of the piston ring is going to be the inner diameter of the piston at the groove plus some tolerance, and we'll figure out that tolerance a little bit later on. The oil scraper ring is a little bit different. The oil scraper ring is kind of made out of two separate rings with a wave washer in between it. So again, if we're looking at this, there's supposed to be a small gap here, but anyway. What you'll notice is that there is a thin ring here, very similar to the one that you have here but thinner, and the same kind of ring at the bottom, and that is spaced out by a wave washer that goes like that and separates this. Let's get this back. Separates this. So this is the kind of plan for today, trying to get most of it done. We'll see how much we'll get through. This is not going to be a fast series. If you are looking for extremely quick tips, then I'm afraid this is not going to be it. But I'm just going to chuck this onto my second monitor, and we are just going to create a brand new drawing, brand new file. We shall call it appropriately. And yeah, let's go start. First thing we're going to do, we're not even going to start with this. We're going to go into the parameter box, and we are going to add our first parameter. Now, unfortunately, when you create your own parameters, you can't really put them into groups and fold them like you would want to kind of organize it a little bit more. So they're all kind of linear. So what we're trying to do is create all the parameters, say, for the bore, all in one go, and then all the parameters for the piston all in one go, and the parameters all for the rod all in one go. Otherwise, what's going to happen is we're going to have our parameter for like one part of the piston here and another somewhere down here, and it's just going to get really messy. So keeping it nice and orderly, we're just going to use parameters in order of our creation, and hopefully that's going to help us out a little bit. But parameters are extremely important. They essentially, it's like creating your CAD model in an Excel-like fashion, where you can just go back into the parameter box and change a bunch of values, and everything, hopefully, if you've created it properly, will just update. So let's create our first parameter. We are going to call it our bore. Bore diameter. Bore diameter is going to be in units of millimeters, and the value is going to be 86. And we're going to click OK. What we're going to do again is we are going to create another parameter. We are going to call it stroke. Now, stroke is just going to be stroke. There's not going to be anything special about that. And we're just going to say 1. What we're going to do is we're actually going to say that our stroke is equal to the bore diameter, like this. And what that means, that currently stroke is 86 millimeters, like bore diameter, and if we wanted to make it bigger, we could say bore diameter add something, or bore diameter times something, and that would make it bigger or smaller depending on what you preferred. Depending whether you want to have a wider piston than the stroke or a smaller piston than the stroke, all depends. So we've got our bore diameter and our stroke. Now we can start defining the piston, because these are really the two only ones that are important. So let's create our first piston diameter. I should really... so there's a couple of things. I'm just going to go back and do a couple of things. First thing first, I'm going to get rid of capitals. It's going to make our life just a little bit easier. Second thing second, there are two kind of ways that you want to do this. For whatever ungodly reason in the parameter softwares in Inventor and Fusion 360 do not like spaces in between the words. So you either, what you can do is do something like this, bore or bore diameter with a underscore in between the words, or alternatively you can write something like this, bore diameter with capital letters in there. This just depends what you prefer. I prefer it to be legible, so I put an underscore in between it. But if you do that, then it's gonna tell you, oh no, I can't do this. So it's a really annoying thing, but it is what it is. So our next is going to be our piston diameter. Piston diameter, and we're just gonna set that to 1. And our piston diameter, to make everything parametric, so everything updates with each other, what we're gonna say is we're gonna bore diameter minus a bore diameter, or just minus 2. Right, so 84 millimeters. We have a little bit of clearance. I was gonna do this as a ratio, but the smaller you go, the ratios have to be different. So piston diameter, bore diameter, and then we're gonna do piston skirt. So if you look at this, what we're talking about is that 25 right there. That's your piston skirt. Piston, or again capital letters, piston skirt, and we are going to set this to 1 at the moment, or 25. We don't have a parameter for that. We've got piston diameter, piston skirt, and we can now do cylinder height. Cylinder height is the height of the actual cylinder itself, which we could have not done without having piston skirt height. So cylinder height, it's going to be okay, or just 1 at the moment. And what we're going to do is we're going to do bore diameter. No, sorry, no bore diameter. Stroke, and then piston skirt height. There we go. And you can see that our cylinder height currently is at 111, which is the sum of our two values. If you see, let's say we change our bore diameter to, let's say, 50, you will see that everything else have updated. Now our stroke represents our bore diameter, and our cylinder height represents all the other values that we have set up. But let's go back to this being 86. I don't know why E6. I think, if I remember correctly, that is the bore inside of my engine, but I can't remember. So cylinder height, piston skirt, so cylinder height, and we can start creating some things. So we are actually going to create our cylinder, or yeah, our bore. So we're gonna create our bore at the moment. We're gonna do this, and we're gonna put this for our cylinder thickness, and we are going to do this. Again, values do not matter at the drawing stage. Because everything is parameterized, what we're gonna do is the moment that we extrude something or make something, we're gonna go back to the parameter box and we're just gonna slap them in. So we're gonna say okay, and then we're gonna extrude that. We're gonna say this, we're gonna say okay. And we are going to go back to modify, change parameters, and we can see that we have one unsaved, sketch 1. Let's first of all name the sketch. So we go into sketches. We're gonna do this as bore sketch without the asterisk, please. Thank you. There we go. We're gonna to modify, change parameters, extrusion 1. So we can see that this is our wall thickness. We do not have a parameter for wall thickness yet, so let's make one. And the thing about this is that, again, this cannot be parameterized as of yet. So we're just going to say that our cylinder wall thickness is 5 millimeters. And we are just going to say cylinder, so 7 point, that's our cylinder wall thickness. When you are making your own parameters up here, you cannot use the same name down here. So we know that our dimension is cylinder wall thickness, 7 point blah blah blah. That's our cylinder wall thickness, but we cannot use the same name. So just change it a little bit, cyl wall thickness, whatever, doesn't matter. Then we copy this, slap on here. Oh, okay, I've accidentally clicked V. Let's get out of here. And let's go here again. There we go. Then we can copy that, paste it here. There we go. Double enter, and that means that the values are representative now. Now cylinder height, that is for our extrusion. So this is again going to be cyl height. Cylinder height. It's going to be 111. And dimension D7 is going to be our bore diameter. Now, because we have said bore DIA, we can write out the full diameter, and we can copy this and pop it right here. So if we click OK now, you can see that our cylinder has updated. And let's just go back to the sketch for a wee second. We can see that the values are, again, representative of what they should be. Click OK. And we can, again, if you look at the bottom right, you can see that the dimensions are what we expect them to be. So yeah, that's our cylinder. We don't want to bother about that, but that is the cylinder itself finished. So it will create a new body. When it creates a new body, you can't really do anything with a body. You can't constrain it. You can edit it and modify it, but you can't do anything with constraints, and we're going to be using a lot of constraints. So you're going to right click on the body, and you are going to do create component from bodies. Click on create component from bodies, click it again, and this is our cylinder bore. So when it comes to naming things in your model tree, this on the left is called your model tree. When it comes to naming things in your model tree, you can use spaces and just write normally, but for some reason in the parameter box you cannot use spaces. So that is a distinction. If you also want to see sketches that you can't see at the moment, like we have used a sketch and Fusion 360 and Inventor and other software default to hiding the sketch after it being used for a single time, you just click this button here, that little eye icon, and you can see our sketch again. But we'll be using that feature later on, so it's not like you will not be able to see it. Now what we're going to be doing is we are going to be creating our piston itself. There is a reason why we've created the bore in the middle. In normal drawing software like Inventor and, well, kind of any parametric software, where you create the part first and then you have to create a different assembly file, it is important to create your part in the middle of the origin point, because that allows you to easily constrain everything. However, Fusion's different. You create all of your parts within one file. So at the moment what you'll see is that because we have created our cylinder bore in the middle of this file, if I try and drag it about, nothing happens, and that is because you see this little anchor right next to here. It is anchored or grounded to where it was created. Now we do not want that for every single thing that we're going to do. In fact, for most things that we're going to do, we do not want this. You can either go right click and unground from parent. We're going to keep this grounded because this actually works in our favor. But you can unground things, and you can ground things to parent as well. Parent, it just means the place where it was created originally. So let's go back and let's go sketch. and we are going to choose this. We're not going to create from the center again, we're going to create somewhere off center. And this is just going to be that, and this is going to be that. Great, okay. So this is going to be the beginning of our piston. Let's go back here actually. This is just going to be a sketch. So construction, if you go into the sketch panel, you've got your construction lines. Constructions allow you to make this. So you cannot extrude a construction line. They're only there to help you model things. And if you go up the top, you have your constraints, which is also a very important thing that we're going to be using quite a lot. I'm not going over anything quite in depth at the moment because there isn't a real need to, because we will be using these things as we go through this entire process. What you can do is you can say, for instance, so we can use this constraint and click on the middle and click on this, and that's just going to plop it down onto the line. The only reason why we want this on the line is because of our origin point, and then we can revolve things around that. I'll show that in a wee second since we're going to be doing this anyway. Gonna click OK, and we're going to extrude this. We're going to extrude this. So the shortcut for extrude is E, but you can also find extrude in our solid create here. Just going to do X amount, doesn't matter. Again, we are going to be going for rough dimensions. And then we're going to go to the parameter box. Let's rename our sketch. We're going to call this piston sketch 1. We're calling it piston sketch 1 because there's going to be like 3 or 4 piston sketches. So this just helps us to organize just a little bit more. We're going to go here, and we are going to go piston sketch 1. And this 95, this is going to be our stern diameter, just our piston diameter. And we have our piston diameter, which is this piston diameter. There we go, 84 millimeters. And our extrusion to piston sketch 1 is going to be piston skirt height. So this is going to be stern. And again, I'm just putting a wee dash at the end of it. And where the piston skirt height. There we go. So that's 25, 84. Perfect. Now, if you go to the left side again, we're going to go to the model tree, and you can see origin. Now, you can put the little drop-down arrow, and you'll see all the origins that we have at the moment. When you click create sketch, it shows you the origin naturally because you want to know where you're creating the sketches from. But you can also do this manually, where you say, for instance, this, and you can choose your origin to sketch from the model tree. Sometimes it's going to be easier to do this. Sometimes it's going to be easier to just click on the screen like this. It all depends. But what we have done is we have put this, our piston, in the center of this line, which means that if we create a sketch on this axis, the XZ axis, we will be able to revolve anything around our piston perfectly around that. So what we're going to be doing now is we are going to be doing our piston ring grooves. To do them, we are going to create on our XZ sketch. We're going to zoom in on this, and we are going to say slice just on the right here. It's going to give us a sliced view of our thing like so. And you can click P for project. We want to make sure that we have this entire thing projected so we can use the sides of the object to scale things from. We're just going to click OK. We're going to just zoom in because this is the only part that we really need to focus on. We're going to create 3 boxes. I can just create a line here. There we go. We're going to create 3 boxes. 1, 2, 3. Their sizes at the moment do not matter. What we're going to do, they're all going to be the same depth. So we're going to create a constraint, collinear constraint, and we're going to say, well, you're going to be collinear to this, and you're going to be collinear to this. Fairly self-explanatory. What we know as well is that this one and this one are going to be the same height. So for the vertical sections, we're going to say, well, you're actually going to be equal to this. These are two constraints, very important constraints for this already sorted. Now we can say that you're going to be 2. It doesn't matter what it is at the moment. Again, we're going to fix all of that in the parameter box. We are going to say for the separation in between them, you're going to be 2.5. And then we want the separation to stay the same. We don't want to change the separation. So we're going to click on that, and then we can click on this and click enter. Once we click enter, it's just going to parameterize. So if I change this to 3, it changes that as well. And what we can do for this is we can say this can be this times 2, for instance, and this is going to just make it twice as high. Now the only two things that we need to do now is we need to define the thickness of it. So 4.7, let's make a 4.55, so it's easy to spot in the parameter box. And the last one is the height from the top, which we are going to make it at 2. And we're going to click OK. You can see that this has made a sketch inside of our piston. Now what we're going to do is we're going to use revolve. We're going to select all 3 sketches, and we're going to choose axis, and we're going to revolve around these axes. This is going to immediately understand that it wants to cut the object, which is going to click OK. Well, these are our grooves. They look a little bit funny at the moment, but let's go back. Let's change the sketch. We're going to say this is piston sketch 2. And what we're going to do is we are going to go back into this sketch. Put this here. We're going to go into modify, change parameters. Let's make this a little bit smaller, like this. And we are going to start defining more parameters in our parameter box. So this is going to be piston groove depth, and let's say it's going to be 3. Again, at the moment it doesn't matter what it is. Piston groove height, let's make that 2. We're going to make piston, no capitals, piston groove separation, let's make that 2 as well. So we've got piston groove depth, we've got piston groove height and piston groove separation, and then piston, no capitals, piston groove from top, which is again a weird way, like we're defining this. This is the piston groove from the top of the piston. I'm sure there is a technical name for each one of these. I'm not using any technical jargon. So we open up piston sketch, and these proportions actually look not too bad. Let's change this 4.5. So piston groove depth is at 3. That feels about right for the sake of this project. So let's actually define these quickly. So our first 2 millimeters is that when we change these at the moment, we will be able to tell what we're actually changing. I know that this 2 millimeters is this 2 millimeters. But on the off chance that you do not know whether that 2 millimeters is this or this, all you need to do is change it and you will know. So let's change this to 2. And this is going to be piston groove height. Now this 3 millimeters is going to be piston groove separation. I'm not too fussed about capitals in these because we're not really going to be parameterizing to this. as in this is not really going to be where we're going to be taking our values from. This is where we're going to be taking our values from. We're not going to name these two because that doesn't, or this one will matter. This is going to be scraper groove height. And the 4.5 piston groove depth, piston groove depth, and the last 2 millimeters is going to be piston groove from the top. Now, piston groove from the top, copy that, paste this in. There we go. Piston groove separation, copy that, piston groove separation, pop this here, and let's change this to piston groove separation. Let's put this 2.5. We could make them as ratios, but we're not going to at the moment. So piston groove at the top, piston groove separation, 4.55 piston groove depth. We're gonna put this right here, 3, and all of them parameterized, 2 millimeters. That is that 2 millimeters. So piston groove height, piston groove. Let me just double check this again. Yeah, piston groove height. So piston groove height, piston groove height, piston groove depth, piston groove depth. Yep. That seems to be looking all right. Let's change this to 1.5. Maybe later on we'll give an actual value. At the moment, I'm not too fussed about that. What we can tell immediately is that our piston is a little bit on the shorter side, so let's change that to a 30, and that just makes it slightly more proportionally bigger. So yeah, there we go. We click OK. This is just going to take a wee second to update. Finish sketch, and this is our piston. It's not looking too bad proportions wise. Maybe what we need to do, change parameters, piston groove height, piston groove depth, separation from the top, let's make that 3.5. Click OK. It looks a little bit better. Alright, but our piston's not tall enough really. So let's change this to piston skirt height, 35. And again, this is the power of being able to parameterize everything, because you're able to do stuff like this. What we can do in the same sketch actually, so if we go back to this, we slice that again. And now we can define the cat that we're going to be using to constrain into the pinhole essentially. So, should we do this or should we do it as a revolve? Yeah, we can do this, but we're gonna do it slightly differently. There's 100 ways to skin a chicken when you do this, and there isn't really any right or wrong ways. There is just more convoluted and less convoluted ways. So let's do that. What we're gonna be doing is we are gonna be taking an imaginary line from here, and we're gonna be doing that line down to here. The beauty of that is that we are not actually creating a new dimension. This is really important because your parameter box should stay as empty as humanly possible, because trust me, it gets really messy. I think my last engine I was at over 1200 parameters by the time that I finished with it. So, and this was me being quite conservative, trying to kind of stay into a reasonable range of parameters. So you do not want to have too many parameters at the same time. The more things you can do with constraints, the more things you can do geometrically, the better it's going to be. So what we're going to do at the moment is we're going to find a center point. Certain center points are defined by that triangle that you see. And you can say how you want your cursor to snap. So sure, there is even a snap to grid somewhere in there, but So we look for the triangle. Oh yeah, so you can click on a line like this, and you've got it into the construction line at the moment. You can click on that to make a normal line, and if we click on that again, you click it and it becomes a construction line. This line in particular we want to keep as a construction line. Right, so now our constructions line is unclicked, so we're going to be using normal lines now, and we can go line, find the center line, and just drag it all the way to the end. And right angles are defined by a square. And do the same thing on this side, like this. Now, is that I don't think that's actually extended, has it? No. So when you see a ball-end like this, it means that the line hasn't fully extended. What you can do is you modify, extend, and that doesn't want to extend for whatever reason. Drag it over. Ah, because there isn't a line there. So you drag it over. Let's create a line here. And then you can use X, I think, or T and Fusion to trim that line to size. This is our center point of our hole. So you go back here, you click this. See that dotted line? This here? That's it right this. So what we're gonna do, we're gonna create another line, just gonna overshoot it on either end, and we're gonna go T, trim, trim, perfectly fine. And then we're gonna dimension. So D for dimension, click here, and we're gonna define how big it is. Let's say 4. Doesn't really matter. Let's say 4. And we can define our groove while we are at this. So the groove is going to be our circlip groove. This is where we're going to put our circlip to constrain the pin, so the pin doesn't fall out when the engine is running. So what we're going to be doing is we're going to be doing this, and we are just going to give it a dimension of width. We are going to give it a dimension of height from the center. I think we're going to go for this. I think that's going to be easier. And we are going to say that this is going to be this times 1.2. So it's 1.5. But bear in mind that when it comes to circlips and you're actually doing this in a real project, there's going to be a specific size for a circlip, and it's all going to change depending on how big or small the engine is. This is just a visual demonstration on parametric design within Fusion 360. We're not creating something that's actually going to run with like in real world. And the last thing you will need is the distance from the edge over here to this, which we are going to create as short as possible. Let's make a 2. Now this shouldn't work, but there is a reason why I'm making it 2, and I'll show you in a second. So let's click out of that. We are going to enable Sketch 2 again because we need to see it. We're going to be working with it, and we are going to go revolve, and we're going to revolve this, and we are going to, that's not closed geometry. If you cannot select something like this, it usually tells you that it's not a closed geometry. And what you can notice is that our right side is created with a normal line, but our left side is created with a construction line. Now again, you cannot extrude from construction lines, and you need a closed geometry in order to be able to do anything in 3D. So you click on this and you click on that, come out of here, and you're gonna go revolve, click on this, click on that, select axis. We're gonna do this. Let me actually cut this in half quickly, like this. There we go. So we're only doing half of it really. And again, is that wise? Yeah, that's wise. And then we're going to be, where is revolve? There we go. That. Select axis here, like this. So you can see that it is indeed created our groove, and it has created half of our tunnel. I'm not worried about the fact that it's half, because we're about to create the other one at the moment. So you're going to go and we are going to create an offset plane. That offset plane is going to be at, let's go back to our cylinder bore, right click cylinder bore, and we're going to go show hide to hide our cylinder, because we don't need that at the moment and it's obstructing our view. We're going to go create construction plane, and we are going to, actually we don't need a plane, we already have one. So mirror, M for mirror, or move object, geez, I'm getting Inventor and Fusion confused constantly. Mirror, mirror on the wall. Mirror. There we go. So mirror is under create and mirror. Control plus forward slash. That's intuitive. Right, so mirror. And we can use our timeline. So your timeline is at the very bottom. It shows all of your sketches and all of your extrusions and revolves and everything, including your joints and all the things that you're going to be doing. And you're going to click on the last one, which is our last revolve. But we need to change from bodies to features. Click on that. Mirror plane. And the mirror plane that we're going to be using is the flat side of the half of our piston. We're going to click OK, and we're going to click OK. Now you can see that this has indeed created a full cut through the piston with our two grooves for the circlip. Again, we have not put any real dimensions on it. What we've done is just created the cuts themselves. Now we can go back to this again, pop it here. We're going to go modify, change parameters, and we are just going to go all the way straight down, which we are already here. We are going to go wrist pin diameter, wrist pin diameter, let's make it, let's make it 8 or 10 actually, why not? Again, I'm not going on off of any real values. If you actually know how an engine works and you think that these values are off, guess what? They are. Click OK. And then we are going to say wrist pin circlip depth. Let's make that 2. So the depth is our 2 millimeter dimension right here. Pin, wrist pin circlip diameter, and let's just say 1. And what we're gonna do is we are going to wrist pin diameter. We're gonna say that times 1.2, which is going to give us 12. It's perfectly fine. Wrist pin diameter, wrist pin circlip depth. So diameter, yeah, depth, and then wrist pin circlip width. What do we have here? We have as 4. 4 is too wide. Let's make that 2.5. Again, this is something that I can't parametrize. There is no real parameter for it, unless I'm able to link it back to Excel and put an actual ISO sheet of all the circlips that could be used for this. So we have this dimension, we have this dimension, that and that. 1, 2, 3, 4. Yep, that all adds up. So wrist pin diameter. And we are going to be doing this with the 4 millimeter. So this is actually going to be this over 2. And this is going to be 7.5 is our this. So wrist pin circlip diameter, which is going to be our this. Over 2. Right, I was kind of, yeah, over 2. That might be a little bit too small, so let's make it 1.4. There we go, a little bit better. We need the 4.44, so wrist pin circlip width. Blah, there we go, and anything that is not parameterized yet, this one, which is the first one, wrist pin circlip depth. Wrist pin circlip depth. And we're gonna do the same courtesy of naming these things. Pin rad, actually, this is a radius. Pin oh, this is actually width, sorry. Just put a little dash at the bottom of it. Again, this is radius. Wrist pin circlip, and this is wrist pin. There we go. Perfect. So when we exit out of this, finish sketch, what we can see is that, let's go back into our modify parameters tab and let's make a bunch of changes. Let's say we want this to be 12. And let's say we want this, actually, you know what, this is too small, let's make this bigger. So yeah, it works. We know it works. We're quite happy with that. What did we have at 5, I think, or 4 even. And wrist pin width, wrist pin diameter, depth. We can push this back even more, or we can keep it out. It's completely up to our creative freedom what we want to do. Right, great. So we have our body now. We're going to right click it, create component from bodies. Create component, this is going to be our piston. Great, we have 2 components now. This is taking longer than normal. However, this is the proper way to make things parametrically. If you want to make things parametrically, the reason you're doing this is because you know in the future you are going to be making a lot of changes, and if you want those changes then to be very quick and simple, especially on larger assemblies, this is the only reliable way to do this. However, you will have noticed that this body we cannot move, however this body we can move. And the reason we can move it is because it is not constrained to the origin like our cylinder bore is. That's a good thing. We want to keep it this way. I think for now I'm going to keep it there. It's been a long enough episode. We have went over some of the basics on a very basic level. We went over some of the harder concepts like changing parameters, but this series is just going to evolve into essentially, well, using pretty much everything that Fusion can provide in order to create this engine. This bore itself is not going to be the block. The block's going to be created completely differently, but you'll see that once we come to it. So I hope you stay and tune in, and yeah, I'll see you next time.